If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in machine series. So today again we will be solving 5 questions starting from question number 81 to question number 85. Okay, then let's try to solve these 5 questions. Okay, in question number 81, a single phase transformer is to be switched to a supply to have minimum inrush current. The switch should be closed at what maximum value supply or zero supply or 1 by root 2, what point it should be switched on so that it should have minimum inrush current. Now what is inrush current is magnetic inrush current, and how do we model that magnetic inrush current? In a transformer model, if you see this one equivalent circuit, so this is modeled as an inductor because this is current magnetization current IM, which lags this supply voltage V. Whatever voltage you are giving, it lags this voltage. So if this is your V, then this is your IM. Actually this becomes your phi also, because due to that IM phi is created. So this is always 90 degree lagging. So if your V starts from here, this is your V sine wave, suppose this is Vm sine omega t. So your IM will start after 90 degree. It is lagging, so it will start after 90 degree. So IM sine omega t. So you need to have minimum inrush current. So if you switched on at this point, so your IM will be minimum and it will gradually start. But if you switch on at this point, suppose this point, then already this has at its maximum value. So at starting you will directly get this much current, which will be very high magnetic inrush current in the starting. So if you need to have minimum inrush current, so you switch it on this position. If you switch on this position, then your inrush current will start from 0. So you will have minimum inrush current. So the idea is to, like your arc quenching type, so that is zero supply, maximum supply voltage, that is at this point. So that means it is your option A, 81. Now if you come to 82, the core flux of a practical transformer with resistive load is strictly constant with load increase linearly with load increases as the square decreases with the increased load. Now core flux phi, that phi is directly proportional to V by F. It doesn't depends on the load. That phi we have seen, that is V by F, because your E is equal to V 4.445 F. So phi is directly proportional to V by F. So it depends on V and F only. It doesn't depend on the load, that core flux. So that's why F is strictly constant with load changes. That is option A. Now if you come to in 83, in a protection of the transformer, the harmonic restraint is used to guard against. We have already seen this one. This is for magnetizing inrush current. In protection you can see we have a detailed discussion how this harmonic constant restraint coil works. So you can check that video in protection purpose, in protection videos, in a playlist for protections. You can see that we have discussed that theory. So magnetizing inrush current, that is 83A. Now if you come to 84, a 3-phase transformer has a rating of 20 MVA, this by this with a leakage reactance this. The transformer reactance in ohm referred to each phase. So you have to find the transformer reactance per phase, that you have to be very careful. On the LV side, delta connected side. So you want to refer it to delta connected. So if you come delta connected side, this side, so your Z per unit per phase, that you have to be careful. So all your bases should be per phase basis. Okay, so your Z per unit is given 0.12. So multiplied by, what is the base this side? It is per phase. It should be Vp and it should be MVAP also per phase. It should be kV per phase. It should be MVA per phase. kV square, actually V square by MVA, but all should be per phase. So it should be 33 square, or you can write 33k square divided by MVA is 20 per phase. It will be 20 by 3. 20 into 10 to the power 6 you can write, if you place 10 to the power 3. Otherwise it will cancel it out automatically. So if you do this one, you will get it is 19.6. That is your option B. So you have to be careful about per phase. Only ZPU, there is no, then we will not take per phase one. We will take overall system base as 20. Then we will calculate, that will be the overall impedance of this one. But if you want to calculate per phase, then you have to think for per phase also, because it is delta connected, so phase voltage and line voltage are equal. That's why you have taken 33. Now if you come to 85, a 3-phase transformer having, in question number 85, in a single phase 3-winding transformer, if the turn ratio of the primary, secondary, tertiary 24:1 with the lagging currents of 50 ampere at a power factor of 0.6 in the tertiary winding, means this winding, find the primary current. So this current will get reflected in the primary. How? The ratio is 1:, voltage is dividing by 20. So current will be getting, because if your voltage divide by 20, so current should get multiplied by 20. So if you come from this to this side, then current should get multiplied. But if this is 50 ampere is giving in tertiary, so from this to this side the voltage is increased, so current should get reduced. So current should be divided by 20. So this same current will get reflected in the primary. So it will be 50 divided by 50 at an angle of cos inverse 0.6, because it is lagging, so minus cos inverse 0.6 divided by 20. So it will be 2.5 at an angle of minus cos inverse 0.6. So find the primary current will be 2.5 ampere, and what will be the power factor? Same, 0.6 lagging. So that is your answer. If you like the video, then press the like button and please give your valuable comments in the comment section.